Hi guys, welcome you all to my channel Explore Edu to Teach.
We learned about each region in detail, like cutoff region, then you have the linear region, the saturation region. So in this class we'll be learning about the equations of this region. Okay, what are the equations in a cutoff region, what are the equations in a linear region, what are the equations in the saturation region. Once these equations are clear to you, we have a numerical that we will be solving. So please listen to this lecture very well. If you haven't watched the last video, it is already uploaded on my YouTube channel, Electronics and Devices playlist. You can go and watch it from there. Try to exactly understand what are these three regions of operation: cutoff region, saturation region, and linear region. Once you understand them, then it will become easier for you to learn these equations and apply them on the numericals. Okay, so all these notes are present in the description box of my YouTube video. Also, these formulas and everything are put in a concise manner on my Instagram page and also on my Telegram group. The links are given down in the description box. If you like my Instagram page, please follow me on Instagram and also join my Telegram group for all the notes and updates. So let's begin with the current equations. So firstly, about the cutoff region. So in the cutoff region, as the name mentions, the drain current is 0 and the value of VGS, that is the gate to source voltage, is less than or equal to VT. Then we have the linear current. Okay, now the linear region has certain drain current equations. Okay, there is a linear region that has certain drain current equations, and there is a N channel and there is a P channel. So remember this thing very well. There is a first of all, there is a cutoff region. In cutoff region, the drain current is equal to 0. Then there is a linear region. Then there is a saturation region. So in case of a linear region, there are two equations. One for a N channel, other for a P channel. So in N channel, we have this equation over here, and P channel, we have this equation over here. I'll read out this equation to you. Once you understand each and every meaning of each and every term, it will become easier for you. So for a drain equation for the N channel linear region is equal to mu n Cox W by L into VGS minus VTN into VDS minus VDS square by 2. And the drain current equation in a linear region for a P channel MOSFET is equal to mu P Cox W by L into VSGP minus mod VTP into VSGP minus VSDP the whole square by 2. So these are the two equations of linear current, a linear region current for an N channel and for a P channel. So in case of your N channel, the conditions, if you remember, the condition for a drain current was that the VGS is smaller than VT. But here for N channel, the VGS N indicates the N channel, is greater than or equal to VTN, and the VDSN is smaller than VGSN minus VTN. Similarly for a P channel, it is source to gate. So VSGP is greater than or equal to mod VTP, and VSDP is smaller than VSGP minus mod VTP. And these are the explanation of different symbols of the terms used in the equation. You can check it from the notes or from my pictures, which will be uploaded on my Instagram page and also on my Telegram group. The links are given down in the description box. Next, we have the saturation region. Now in case of your saturation region, if you see, we have again two channel, N channel and P channel. So the N channel equation says mu n Cox W by L into VGSN minus VTN the whole square by 2, and ISDP is equal to mu P Cox W by L into VSGP minus mod VTP the whole square by 2. And these are the conditions for an N channel and P channel. I hope I am very clear. So here is the numerical that you have. Okay, the diagram is given to you over here. These are the parameters of this MOSFET. Okay, the parameters are mentioned. You have a M1 MOSFET, you have a M2 MOSFET, both are N channel MOSFET. The threshold value is given as 1 volt. The M2 is said to be as on. They are telling you to find out the value of Vx over here. That is the source voltage of M2 or the drain current voltage of M1. So now if my N2 is on, Okay, I need to know the region in which it operates. So since my M2 is on, I can say that my VGS is going to be greater than VT. Okay, so what is happening is, if you look from this diagram given over here, my M2 के लिए the equations are going to be drain as 3 volts, the gate as 2.5 volts, the source voltage as Vx, and VT as 1 volt. So to check if M2 is already given as on, so there's no need for us to check whether it's on or off. So if M2 is on, we need to identify the region in which it operates. It can be either linear or saturation. So the equation that we have is VDS, VGS minus VT. So VDS is VD minus VS, VGS is VG minus VS. So VS cancel. VD is equal to 3 volts. VG is 2.5 volts. VT is 1 volt. So 3 is greater than 1.5 volt, and my M2 is, since my VDS becomes greater than VGS minus VT, I can say my M2, MOSFET M2 lies in saturation region. Now you have to understand what does M1 lie into. Now M1, you have to first find out whether it's on or off. So if you see, my VGS is greater than VT over here. For a M1 given over here, the VGS is greater than VT, hence my M1 is on. Now if my M1 is on, I need to identify the region in which it operates. So we are going to assume it to be in saturation region. It's just an assumption. It can later be changed to linear region also. So what we are going to do is that the current ID2 is over here and the current ID1 is over here. Okay, so this is very important, that is ID2 is equal to ID1. Okay, so since these two MOSFETs are in series, I can assume that the ID2, the current through MOSFET 2, is equal to current through MOSFET 1. So just write these equations over here and we'll get the final answer of Vx. Now the Vx value has to be chosen in such a way that my MOSFET remains in on condition. Therefore, for value of Vx as 0.5, my MOSFET is in on condition. So for all these steps are properly given in my notes. They will be uploaded on my Instagram page, on my Telegram page, and also the links are down in the description box. Please check it out. So in short, if I have to summarize, this is basically the regions in which the MOSFET operates. You have the cutoff region, you have the linear region, and the saturation region. The equations are given to you. Based on the question, just do step by step. All these steps are explained properly over here and you can understand what is happening. So if you have any doubt, please comment in the comment section. You can also ping me on Instagram, DM me on Instagram also, and also on my Telegram group. I will try to answer your questions.